Alright, this is Mr. Gillum, and today we're going to learn a little bit more about the Pythagorean theorem and some of its applications. Alright, now there's a little bit here about Pythagorean triples, and I've barely touched on it with you a little bit. The most familiar Pythagorean triples are the 3, 4, 5 and the 5, 12, 13. The ones that don't stick out near as much to me are the 8, 15, 17 and the 7, 24, 25. But this chart is just more of a reference than anything, because I know we've talked about this a little bit in the past. So any uh, scale of 3, 4, 5 is also a perfect right triangle. It's called a Pythagorean triple. So if it's a 6, 8, 10, and 9, 12, 15, I'm just multiplying the digits of the 3, 4, 5 by 2, by 3, and so on. And that's just represented here by this last part. And the same thing here, 5, 12, 13 is guaranteed. And the reason they're called Pythagorean triples is because 3 squared is 9, 4 squared is 16, it always equals 25, which is 5 squared. And it works similarly, 36 plus 64 equals 100. And 81 plus 144 equals 225. And I mean, it factors the same way every time. It works out all the time. Same way with these other two combinations, 25 plus 144 is 169, and so on. But even the multiples of that Pythagorean triple are, in fact, Pythagorean triples. I mean, they're right triangles. They're common sides that are whole numbers that could be the sides of a right triangle. So I might refer back to this chart because I'm not near as familiar with the 8, 15, 17, and 7, 24, 25 as I am with the 3, 4, 5, and the 5, 12, 13. Before we go on, though, I do want to make sure that we're all clear. The c-squared value in your Pythagorean theorem is always the hypotenuse. So the legs, it doesn't matter which order you use them in. I could use 4 squared plus 3 squared or 3 squared plus 4 squared, but always it must be equal to 5 squared, the hypotenuse. And we know it's the hypotenuse because it is the longest side. That's very important. So I'm going to use Pythagorean triples to just solve for the values of x here. And so for some of you, it's going to be you're going to be very happy because you're not going to have to show any work for these Pythagorean triples. So in this case, I know right away that x equals 9. And so to kind of show you where these things are coming from, if you look back here, we had a 12 side and a 15 side, therefore it must have been 9. And we can only use that if we're sure that we have our c side as the hypotenuse. And you can look and see which one's the hypotenuse by looking at the one across from the largest angle, or in this case across from the 90-degree angle. We are using Pythagorean theorem. So the x value would have to be the c value. So I'm looking for legs that have 20 and 48, or multiples of a Pythagorean triple that will give me legs of 20 and 48. So in this case, I'm looking for two legs, so the first two numbers here somewhere, that would be 20 and 48. Now on this chart, I don't see any, but I do see 10 and 24 instead of 20 and 48. So I know that if I double this second part here, if I want one more down, I would know it'd be 20, 48, and 52. So I know this Pythagorean triple would be 52. All right, just Pythagorean triple exercise. And you're going to have to refer back to your chart likely on a lot of these until you get more familiar with them. Okay, so in this case, I'm missing a leg, so I know it's going to be one of my middle numbers here, and obviously this side's going to be shorter than this one. So I'm going to be looking for the second number in my Pythagorean triple of the multiples of 14 with a multiple of 50 for my hypotenuse. So let's take a look back at the chart here. I have a leg of 14, I need the other leg, and I know my hypotenuse is 50. What I notice right here right away is that my hypotenuse number, which is always the last number here, way back here on this Pythagorean triple, the 7, 24, 25 Pythagorean triple, does have an hypotenuse with 50 and a leg of 14. So in this case, I must know that the last side is 48. So instead of doing a big factor tree Pythagorean theorem, all that work and nonsense, using these Pythagorean triples be handy for you, because you can just find the length, and it's just always going to be the length, and any multiple of those Pythagorean triples is always going to be a right triangle. So there's just a little review on a Pythagorean triple if you didn't know that before. It might be worth it to take the time to at least memorize the first Pythagorean triples, the original Pythagorean triples, and then so I would try to remember 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25, because that knowledge is going to help you a lot for this assignment. Not only that, but later on when we do special rules of triangles, it's going to be important then as well. And so now also, instead of just the Pythagorean theorem itself, let's talk about the converse of the Pythagorean theorem. Okay, it says that if the sum of the square of the length of the shortest sides of a triangle is equal to the length of the longest side, then the triangle is a right triangle. Okay, this we know because if a squared plus b squared equals c squared, it is a right triangle. Okay, so we're flipping around. Instead of saying, oh, this is a right triangle, a squared plus b squared must equal c squared, we're saying a squared plus b squared does equal c squared, therefore, opposite the hypotenuse, there must be a right angle. Okay, so we're using the converse of the Pythagorean theorem. We're just switching it around a little bit. No new information, just using the converse instead of the actual theorem itself. Okay, so it kind of works well, Pythagorean theorem, because if the c squared value happens to be smaller than the a squared and b squared values, then the triangle is actually acute instead of right. And if it's bigger than the a squared plus the b squared values, then the triangle is actually obtuse. All right, and of course, if it's equal, we know it is a right triangle. So it's pretty, I mean, to me, it would make sense really easily to say, oh, well, is a squared b squared plus b squared equal to c squared, bigger than c squared, or less than c squared? If it's equal, it's a right. If it's bigger, it's obtuse, which would make sense to me in my head. And if it's less than, it would be acute. So hopefully it'll be quick and easy for you to remember as well. Let's take a look at these. And like I said, I want to make sure that everybody's clear on this. The biggest number has to be the hypotenuse. So 16 must be the hypotenuse. 41 must be the hypotenuse. Okay, it must be the side on that side of the equality. All right, so I'm going to put a dashed line here. I'm going to say, okay, 16 squared, 41 squared. We're just kind of doing both at the same time. Okay, I need to figure out this whatever sign is going to be in here. Okay, if it's greater than, it'll be obtuse. If it's less than, it'll be acute. If it's an equal to, it's a right. So I know 7 squared plus 14 squared. All right. So I just happen to have a calculator right here. I'll quickly do that. Is 256 greater than, less than, or equal to 49 plus 196. So we have 256 and 245. So whatever my sign is here, if it's greater than, it's obtuse. If it's less than, it's acute. And if it's equal to, it's a right. It's not equal to, it's definitely not a right triangle. This hypotenuse squared is bigger than the sum of the legs squared. Therefore, it is an obtuse triangle. All right. Justifying your answer would be this work. That's fine. Okay. And so, again, I know that the hypotenuse squared is going to be either bigger than, less than, or equal to the sum of the two legs squared. So let's take a look here. 41 squared is 1681. 9 squared is 81. 40 squared is 1600. And, you know, I bet this was a Pythagorean triple multiple. All right, let's see here. We have 1681 and 1681, so they are equal, therefore it must be a right triangle. Okay, it's a right triangle. And that's pretty much it for today. If it's, like I said, if you're using Pythagorean theorem for side lengths and it's equal to each other, it's right. If it's less than, it's acute, and we didn't have an example of that, but if it's greater than, the hypotenuse squared is greater than the leg squared, it's obtuse. So hopefully you can remember that, as well as start getting familiar with the Pythagorean triples here. So, all right, that's it for today.